Well friends, we have to remember one thing. The way I have written R2 and X2 over here, it has to be basically when the current is drawn from here, what is happening, the drop is also happening into the primary winding. So we can say that the entire drop that we are having, it is into RO2 and XO2. Fine. So the entire thing will remain same except this will become ZO2 and this is RO2, XO2, RO2, XO2. Fine. Everything is same. Fine. Clear? Okay. So now, based on the understanding that we have got for the regulation, we have got a nice, chalo, I'll draw it again. We have got a nice example. A 230 volt, 230 460 volt transformer is there. The primary resistance and reactance is a given. Secondary resistance and reactance is a given. Find V2, find the output voltage when I2 is equal to 10 ampere at pointed power factor lag. Fine. I'll need a calculator actually. હું લઈ આવું મારું. You should also be having your calculators along with you. It is preferred. So let us visualize what exactly is given to me. This is my transformer. This is my transformer and primary winding, secondary winding. Secondary would be having naturally more numbers of turns, right? Because we are having more voltage in secondary. This is R1. This is X1. And this is R2, this is X2, and some load is connected over here which is actually fetching 10 ampere current at pointed power factor lag. Pointed power factor lag. So you can understand as if your load is, you can model your load as RL series circuit. Fine. So that's why it is taking some 10 ampere current, and naturally at that time some voltage would be here. Fine, some voltage would be here. You are supposed to calculate the value of voltage. अगर ये Z load दे दिया होता तो current multiplied by Z will give me the voltage. Z is not given to me. Current is given to me at some power factor, 0.8 power factor lag. So we have to calculate cos phi, which is equal to 0.8. So phi which is equal to cos inverse 0.8. Fine. So cos inverse 0.8 comes out to be 36.86. 36.869. So 36.86 degree. Fine. 87 कर दो चलो इसको. So phi is equal to this. Fine. पता चला? Now this is a lagging current, so that's why my phi would be negative. यहाँ पे दिक्कत आती है. People cannot understand this. Lagging is given to me, and that's why my angle of current would be negative. I have taught you why it would be negative. Just now in the previous theory I have taught you how exactly it becomes negative. Okay, so now I can say that my current, visualize the vector diagram simultaneously. We are having some V2 voltage that I'm supposed to calculate. I have to find this value. I have got the magnitude of current which is 10 amperes and it is at 36.87 degree. Is it clear? Fine. So if I want to just write down my current as a quantity, I'll say that current which is equal to 10 at an angle minus 36.86 ampere. बच्चों को ये नहीं clear होता. पता चला? From given data, how to identify this? You're done? Fine. Okay. Once you have got the value of current, you know, one more big thing is remaining. I know this will become I2 RO2. And this is I2 XO2. Now again, I don't have the values of RO2 and XO2. Do I? I don't have. I have R2 X2. I have R1 X1. What is the value of RO2? So it is R2 plus R1 dash. And R1 dash is what? Primary resistance referred to secondary. So when this transformation happens, you have to multiply it with k square. Fine. So we can say that RO2, which is equal to R2 plus k times k square into R1. Fine. R2 I already know, 0.75 plus k square. Now k square is what? The transformation ratio, 2 upon 1. 2 upon 1. What is like n2 upon n1 or v2 upon v1? So 460. So we have got the value of k, which is equal to 460 divided by 230. Comes out to be 2. I'm so sorry, right? So this is 2. So we have got 2 square into R1. What is the value of R1? 0.2. So we'll be having 0.75 plus 4 times 0.2. So 0.75 plus 0.8. Can you see these two are really similar, almost equal? Can you see that? पता चला कितना आया? 1.55 ohms. So RO2. You can see these are almost same. The value of R1 dash and R2 is almost same. Fine. Okay. Now let us find out XO2. So XO2 will be x2 plus x2 dash, x2 plus k square into x2 dash. X2, the value of x2 is 1.8 plus 2 square into 0.5 comes out to be 1.8 plus 4 by 2, which is 2. So it is also very near to each other. So we'll be having 3.8 ohms. So XO2 is also clear to me. Is it done? Fine. So once I've got these two values, I can easily calculate V2. Fine. So I have got R to XO2 and my no load, my full load voltage is what? Full load voltage is equal to no load voltage. Sorry, this is no load voltage is equal to full load voltage plus क्या था? I2 RO2 cos phi 2 plus I2 XO2 sin phi 2. Is it clear? This was the formula. So I can easily calculate. V2 was what? To 400. Sorry, we are supposed to calculate that, right? So V2, which is equal to V2 no load minus I2 RO2 cosine of phi 2 plus I2 XO2 sine of phi 2. So we can say that V2 no load कितना था? 460 volt minus I2 कॉमन निकाल ले. I2 कितना है? I2 10 एम्पियर कॉमन निकाल लिया. RO2 कितना है? RO2 is equal to 1.55 ohms. cos phi कितना है? It is 0.8 plus XO2 कितना है? 3.8. sin phi 2 कितना है? 0.6. पता चला कि नहीं पता चला? Clear हुआ? Fine. So we just have to do this calculation. So we have got 1.55 into 0.8 plus 3.8 multiplied by 0.6 is equal to this into minus 1 plus multiplied by 10 plus 460 comes out to be 424.8 volts. 424.8 volts. So we've got the exact answer. So this is my full load voltage, and if I want to go for regulation, I can go for regulation very easily. I know what is full load voltage, I know what is no load voltage, and divided by full load will give you the regulation. Is it fine? Okay. So in this topic we just have been asked with this, what is the full load voltage, right? Okay, you have to remember that you have to take the values of RO2 and XO2 here. Fine, never forget that. Write down.